In this video, I'll discuss about how to perform exploratory factor analysis in SAS. The confirmatory factor analysis will be covered in a separate session. What are the things that I am going to cover in this session? First, I'll do a correlation check of the variables. I'll also talk about how to use a proc factor for doing factor analysis, and then I'll also cover the options available with proc factor in doing factor analysis. Make sure you have gone through my video on factor analysis theory. The name of the video is factor analysis, wherein I have covered the theory on factor analysis before going to this video. To illustrate this particular topic, I'm going to use a data set. Let me show you the data set. The data set has information on the school students. It's about the performance of the students in class. What are the variables available to us? We have mother education, father's education, family income, score in English, mathematics, science, social science, natural science, and vocabulary. Okay. After factor analysis, I am going to build a model based on the performance of the student. I am going to categorize student into good and bad. Okay. With some criteria, I have categorized with student type 0 and 1. 1 is good and 0 is bad. But student type variable, which is a binary variable, is not going to be used for factor analysis. Okay, so that is going to be used in the future regression model. That's the reason why I have this variable in my data set, but this variable is not going to be used for factor analysis. Okay, what is our objective? Well, the objective is that when we will do a regression model, I'm going to do a logistic regression model. Once the factor analysis, I have the factors in place, I'll regress student types with all the other variables, right? So that's my regression equation is going to be. How many independent variables I have? From mother education to vocabulary, I have 8 independent variables, and student type is my dependent variable. Okay. Now we have 8 independent variable, and there seems to be some kind of a redundancy in the data. So instead of using 8 independent variable, we can get down to a very few number of factors. The objective of this session is how to reduce a number of variables. We have 8 variables here to a very few number of factors, and then use these factors for the regression model. Got it? First thing we will do is to see the correlation. We will do the correlation check first. I'm using all the variable except student underscore type. As I said, that particular variable is not going to be used for factor analysis. Let us go to you can see that there is high correlation among variables. High correlation between vocabulary skills and English. Makes sense. highest correlation between vocabulary ability and then social science. Hence, we can conclude that there is some level of redundancy in our data. And when we have redundancy in the data, we need to use factor analysis to come up with a few number of factors out of this large number of variable. We don't have a large number of variable, but we can of course reduce the number of variables from 8 to a very few number of factors. Proc factor is the SAS proc that is used for factor analysis. Proc factor data, name of the data, and then in var you mention all the variables that you want to use in factor analysis. This is the simple form of proc factor syntax. There are options available. We will use the options later. Let us run the simple, the very simple version of proc factor. You will have so many things in the output. Not everything will be covered in this session. The important things will only be covered. You can see a message that 2 factors will be retained. So proc factor says that out of these 8 variables, you can make these 8 variables into 2 factors. Okay, we can group the 8 variables in such a way that we will only have 2 factors in place. We never asked SAS to group them into 2 factors. It's SAS by certain criteria. Well, the criteria is Bayesian criteria. You can read the SAS manual to get to know more about this criteria. Using that criteria, SAS tells us that 2 factors will be retained. Okay. Let's go to the box factor pattern. You can see there is factor 1 and factor 2. Automatically we have 2 factors in place, directly given from the algorithm. Now how do we know that? If you remember my session on factor analysis, what I told is that each and every variable is a linear combination of the factors. Okay, let's take this variable mother's education. So mother's education is a linear combination of factor 1 and factor 2. The coefficient, okay, this is the estimated coefficient. The estimated coefficient for factor 1 is 0.41 and that with factor 2 is 0.69. Similarly, for father education, the estimate, the coefficient of factor 1 is 0.5 and the estimated coefficient for factor 2 is 0.69. Okay. We can write it down like this: mother's education equal to 0.41 factor 1 plus 0.6 factor 2. Similarly, we can write such equation, this type of equations, for all the variables that we have used. Now remember one thing, if you remember what I talked, what I taught in the factor analysis video, the theory part I'm talking about. Out of the two coefficients, look at the one which is having a higher value. Okay. Usually, one of the coefficient will be significantly higher than the other. This coefficient for factor 2 is significantly higher than coefficient for factor 1, right? So 0.6 is greater than 0.4. Okay. Hence, mother education is explained more by factor 2 and less by factor 1. Got it? Hence, mother factor 2 is contributing more towards explaining mother's variation in mother's education. So factor 2 is the latent factor associated with mother education. Now let us go back to the result and see where factor 1 is contributing more. If you see English, the coefficient for English score is 0.77 for factor 1 and minus 0.23 for factor 2. Hence, factor 1 is contributing more to the English score than factor 2. Similarly, mathematics. Factor 1 is 0.77 and factor 2 is 0.17. The coefficient for factor 1 is significantly higher than coefficient for factor 2. Hence, factor 1 is contributing more to the mathematics score. Okay. So there is a trick here, how to club variables, right? We have got factor 1 and factor 2. So how to club variables into separate factor? Okay. Wherever you have higher coefficient, just mark it. First variable mother education, I'll mark this one. Second variable father education, factor 2 coefficient is higher, again I'll mark the second one. And then family income 0.6 against 0.4 for factor 1. So coefficient for factor 2 is higher. Hence, and no other cases, right? In no other cases you have factor 2 having higher coefficient. So only first three variables are the ones where the coefficient for factor 2 is higher than coefficient for factor 1. Hence, the first three variables, mother education, father education and family income, can be clubbed together. Okay. So that come under the factor 2. Okay. In the last 5 variables, in all the cases, the coefficient for factor 1, you can see it, is higher than the coefficient for factor 2. Hence, we can club these 5 variables into factor 1. Okay. So that's how we group the variables. Factor analysis is all about grouping variables into one single factor. Right? Okay. Remember, this is exploratory factor analysis. So we have no clue, no hypothesis to start with. We do not have any knowledge or very little knowledge about how the variables actually behave, or if there is any pattern, if at all there is any pattern among the variables that we have used. Okay. The SAS algorithms suggest us that we should be taking only 2 factors, but we have the option of selecting the number of factors. How do we do that? We can use the n factor criteria. Okay. So when we use the n factor option, we can mention there how many factors do we want to be there in the result. Okay. If we want to enforce it, if we don't want to enforce it, we just want to explore it, we can just let the algorithm find it out for us. Okay, that's about exploration. I told, right, proc factor is used for data exploration purpose. So we start with no option, then we go on with options and then keep changing the options to see if there is more pattern coming out from the results. Okay, let me give 3. Let me see what happens if I ask SAS to give me 3 factor instead of just 2. Let me see the factor patterns. You can see in the output there are 3 factors. Remember the way we group the variables. I talked about how to group variables, right? Now, when you have 3 factors, look at the coefficient which is the highest among all the factors, all 3 coefficient of 3 factors. For the first variable, it's factor 2 coefficient. Second variable, again, it's the factor 2. Similarly, in the third variable also, it's the factor 2. Okay, and then I don't see any valuable thing happening by enforcing 3 factor. The reason is because most of the pattern in the data is being explained by factor 1 and factor 2. Factor 3 is useless because except natural science, where not even natural science, yeah, I don't see even any place there is no variable where the coefficient of factor 3 is the highest among all 3 coefficients, right? Can you see? Yeah, I can't see that is there anywhere. So factor 3 doesn't add much of value to our analysis, right? So we can try it out, like we can keep increasing the number of factors and see what is happening. Okay, that is the way we do the analysis. As I told in the very beginning itself, that we don't go with any hypothesis, any knowledge. We just keep on exploring. So number of factor is 2. We could see that if we have 2 factor, that is enough. That explains our data set. The next thing that we will study is how to plot a Scree plot. To plot a Scree plot, we use the option Scree, SCREE. Let me run this. Well, what is Scree plot? Well, it's nothing but it's a plot of the eigenvalues, and then this particular plot is used to find out the number of factors that should be retained. SAS suggests us that we should be using 2 factors, but we are not sure of it. I mean, because it's an algorithm at the end of the day. How do we select the number of factors to be retained? Look at this plot. Look at this plot. It keep decreasing, then it become flat, right? So there is an elbow-like structure. There is an elbow-like structure of this plot. Wherever we see the elbow, after the second eigenvalue, you can see that all the other eigenvalues are lying on more or less on the same line, right? The elbow-like structure is there at the second eigenvalue, and that is the way you select the number of factors to be retained. Okay, so we will retain only 2 factors. Now, had it been the case where if this third eigenvalue, right, it would have been somewhere here, and the elbow-like structure would have been there at the this eigenvalue, then we would have retained 3 factor instead of 2. But here it's there with the eigenvalue 2, hence we will keep only 2 factors. That is the use of Scree plot. The next thing that we will study is about rotation, a factor rotation. Let's go back and see the factor pattern. There are 2 factors in place. Factor pattern gives us the coefficient that is estimated by using the estimation algorithm, and we find out that which variable is related to which factor, right? We group variables based on the factor loadings. We call it actually factor loading. Instead of coefficient, we actually call it factor loading. Rotation is a method using which we can discriminate between the factor loadings better. So what do you mean by that? Well, the factor loading for the variable father's education is 0.5 for factor 1 and 0.6 for factor 2. There is not much of a difference between them. Rotation helps us discriminating the factor loading. That means making it the distance between the factor loading for one factor and the other factor, making it maximum. Okay, so that it can be clearly distinguishable. Okay, what it essentially does inside the algorithm is that it orthogonalizes the dataset, orthogonalizes the factor scores. Okay, what is orthogonalizing? That means it makes sure that there is a 90-degree or the 2 data sets are perpendicular to each other and not very correlated to each other, and ensuring that the factor loadings are entirely different and there is a distance maintained between them. Let us use it, it will be more clear. We use the option rotate equal to, well, there are several types of rotations available based on the fact that whether we want correlation between factor loadings or not factor loading, factor scores or not. Okay, so before rotation, let me tell you how to get factor scores, right? When we combine variables, we need to get factor score, right? Actual number. Okay, because if you study that first and then go to rotation, it will be easier to understand because things are confusing sometimes. We get it by using the out option. I'll save the factor scores along with my input variables in another data set. I am naming it as students1. You can name anything. Let me go to students1. You can see the last 2 columns, factor 1 and factor 2. You have the values for each and every set of observations. So that is nothing but a combination of several variables together to come up with factor scores. Factor 1 and factor 2 are the final variables we have from a whole set of variables. Only these 2 variables will be used for further analysis. Okay, we call them factor scores. Now let's go to the code and we will use rotation on them. Rotate. For rotation, I use the option rotate. There are basically 2 types of rotations available. Okay, one type of rotation, let me write it, is orthogonal. The other one is oblique. If we want our factor scores to be totally uncorrelated, remember the problem from which we started. We started from high correlation data, right? So we don't want high correlation in our factor. We went into factor analysis just because there was a presence of high correlation in my data. So we don't want any correlation among the factor scores. Okay, no correlation between factor scores. That's one of the way of handling it. Sometimes it's very impractical to impose this condition. Having no correlation between two variables is very impractical, very unrealistic. And sometimes in a modeling setup, we want some correlation, some practical correlation between these two factor scores. Okay. In such scenarios, we use oblique rotation. Some correlation exists between the factor scores. So that's another type of rotation known as oblique rotation. I'll discuss only about orthogonal rotations. That's the most popular one. We don't go into the strictness criteria. Most of the times orthogonal rotation is used. For orthogonal rotation, we need to use rotate option. Rotate equal to vary max. If you want to use oblique rotation, just mention pro max. Okay, rotate equal to pro max. PROMAX. If you are using vary max, it's going to rotate in orthogonal fashion. Let me run it. Let me go to the factor patterns. Yes. When you mention the rotation option, you will get two factor patterns. The first one is the unrotated ones and the second one is the rotated one. Okay, this is the first one. The first factor pattern in your output in your result is unrotated one, 0.4, 0.6. Remember these coefficients, the factor loadings, and let's go to the rotated one. Rotation method vary max, from where the rotation output is there. Now look at the factor loadings. In the unrotated output, the difference between the factor loadings for mother education was very little, right? 0.6 and 0.4. Look at here, 0.4 and 0.08. There is a it's clearly seen that factor 2 is the one which is more related to mother's education. Right. Similarly, second variable, father's education. Clearly it is seen. There is no confusion at all. There is a distance between the factor loadings. Very high distance between the factor loadings for father's education. Similarly, for all the variables you can see. Okay. Again, I'll repeat how to group the variables into factor. Compare the factor loadings and then mark it. The best thing I do is that I take it to Excel and then I mark it in yellow or something. Okay, you just highlight it and you will get to know. And for mother's education, second factor, father education, compare the two loadings. The one which is higher, again you just mark it. First three variables are associated with factor 2. We group them and call them factor 2. The next 5 variables where the factor loading for factor 1 is higher than the factor loading for factor 2, I group them in one particular factor and we call them as factor 1. The next thing we will learn is how do we interpret these factors, because if we use factor 1 and factor 2 in the model, nobody is going to understand what a factor 1 is and what a factor 2 is. So how do we give a name that is understood by the by everyone? Like if we are going to explain this model to somebody else, we need to give a name to factor 1 and factor 2. Well, mother education, father education, and family income show or indicate the family status of a child, whether he has come from a good family background or not, whether your parents are educated and having higher income or not. So that's about the family background or family status. So instead of calling factor 1, we can just rename it as family background factor. Family background factor. So that's our new name. That's the new name of our factor 1. And that is easy to understand, right? The next factor is factor 2. It has 5 variables, right? English, mathematics, social science, natural science, and vocabulary. Well, we can call it as academic. What do we call it as? Quantitative and verbal ability. We have clubbed them together. Of course, we can make it 2 separate factors. I tried with 3 factors. I was thinking maybe we can have a factor for quantitative scores and then verbal score, but they have been clubbed together in factor 2. So we can call it as verbal and quantitative ability of the student. We can just use the rename statement in the data statement, like data students 1 rename factor 1 is family background, factor 2 is quant and verbal ability. Okay, the further analysis that we will be doing on this on this factors is to model for whether a student is a good student or a bad student. As I have already shown you, the dependent variable is student type, which is a dichotomous one, so we'll be using proc logistic, right? Student type is my dependent variable. Instead of using 8 variables now, I'll be using only the 2 factors. Family background factor and then the quant and verbal ability of the student. It's a simpler model having fewer number of variables and easy to explain to someone. We can of course explore more, make the factor better and more understandable. Okay, we can explore more and more about it to make the model easy to understand. That's how we perform factor analysis. To summarize, we start with correlation. We check for correlation first, and then if we find high correlation, we go in for factor analysis. In factor analysis, we use so many variables and then come up with a few number of factors. We can save the factor score in a different data set and use the factor score for further analysis. We use rotation to make sure that the factor loadings are very clear and it's easy for us to segregate between two different factors, which variable is related to which factor. And then we use Scree plot to know the number of factors that is to be retained. The factor scores are finally used in the regression modeling or whatever kind of analysis that we are going to do with this data set. That's how we perform regression factor analysis. Thank you.